In the vastness of space, where the sun reigns as the life-giving star of our solar system, a silent storm has been brewing, one that NIS's most powerful observatories and satellites have now detected with growing alarm. For centuries, humanity has looked up at the sun as a constant, predictable source of light and warmth. But recent findings suggest that beneath its brilliant surface lies a dangerous secret, a looming solar catastrophe that could threaten life on Earth as we know it. It all began when NASA's solar observation satellites picked up strange fluctuations in solar activity far beyond what scientists had ever recorded before. These weren't the usual solar flares or coronal mass ejections that come and go with the sun's natural 11-year cycle. This was something far more complex, more unpredictable, and potentially far more devastating. The sun, it seemed, was entering a phase unlike any we have witnessed in modern history, a phase where magnetic fields twisted violently, sunspots grew larger and darker, and powerful bursts of charged particles raced outward toward the planets, with a speed and intensity that left scientists both fascinated and deeply concerned. NASA's experts began warning that this unusual solar behavior might lead to a catastrophe, a massive solar storm so strong it could disrupt satellites, power grids, communication networks, and even endanger astronauts in space. The implications were frightening. The fragile technology that modern civilization depends on could be thrown into chaos in a matter of minutes, leaving billions vulnerable to a digital blackout and exposing Earth's atmosphere to dangerous radiation. As NASA's probes sent back ever more detailed data, the picture grew darker. The sun's magnetic poles, which normally flip every 11 years in a well-understood rhythm, were acting strangely, with delayed reversals and strange fluctuations that could indicate a buildup of immense magnetic energy. This energy, when released, suddenly could trigger solar superstorms far more powerful than anything humanity has seen, potentially eclipsing the massive Carrington event of 1859, the largest recorded solar storm in history, which had already caused telegraph systems to fail worldwide. Scientists warned that this time, the stakes were much higher because of our dependence on electrical infrastructure, GPS, and global communication satellites, all vulnerable to intense solar radiation. NASA's models suggested that the upcoming solar cycle could bring storms capable of causing power outages lasting weeks or even months, crippling transportation, water supplies, and emergency services. But beyond technology, the threat to human health was also serious. Astronauts outside Earth's protective magnetic shield could be exposed to lethal doses of radiation, and even commercial airline passengers flying at high altitudes near the poles might face increased radiation risks. Behind the scenes, NASA's teams worked tirelessly, developing early warning systems and strategies to protect critical infrastructure, while also collaborating with governments and private companies worldwide. Yet, the uncertainty remained. When exactly would the next big solar storm hit? How powerful would it be? Could humanity survive such a catastrophe unprepared? The mystery deepened as data revealed unusual solar phenomena never before recorded. Massive filaments of plasma twisting across the solar surface, sudden bursts of gamma rays, and strange oscillations that hinted at forces beyond current scientific understanding. Was the sun simply behaving according to natural cycles we don't yet fully grasp, or was there something more ominous at play? Some experts speculated about the possibility of cosmic influences, perhaps a nearby star or interstellar cloud affecting the sun's activity, adding another layer of mystery to the unfolding drama. Meanwhile, social media buzzed with speculation and fear, conspiracy theories flourished, and public concern grew. NASA struggled to communicate the real risks without causing panic. balancing transparency with reassurance while urging governments and individuals to prepare for worst-case scenarios. As this invisible threat loomed closer, scientists urged global cooperation and investment in solar research, space weather forecasting, and infrastructure resilience. The stakes could not be higher. A solar catastrophe could erase decades of technological progress in hours and force humanity to confront its vulnerability in a harsh cosmic reality. The question that echoed through NASA's halls and into the hearts of people worldwide was clear and urgent. Is Earth truly facing a solar catastrophe? And if so, can we survive it? This was no longer science fiction or distant possibility. It was a race against time to understand the star that gives us life, but now threatens to change it forever. And as NASA's satellites kept their watchful eyes fixed on the roiling surface of the sun, the world waited with bated breath, knowing that the next great solar event could come without warning, altering the course of history in ways we can barely imagine. Imagine the sun, the constant star we have relied upon since the dawn of time, suddenly behaving like a wild force of nature, unpredictable, dangerous, and ready to unleash power unlike anything seen in modern history. NASA's latest findings reveal that the sun's magnetic fields are twisting and knotting like never before, building a tension that could break loose at any moment. This tension causes solar flares and coronal mass ejections, massive bursts of charged particles and radiation that shoot out into space, and if aimed toward Earth, can fry satellites, knock out power grids, and disrupt communication systems that our daily lives depend on. What makes this new threat so alarming is its scale and timing. Scientists studying the sun's activity noticed that the current solar cycle, which normally follows a predictable 11-year rhythm, is behaving strangely, with unusually large and frequent sunspots appearing, and the magnetic poles hesitating to flip, signaling a buildup of magnetic energy that could explode into a superstorm. The consequences of such an event are difficult to fully grasp because modern society is deeply dependent on technology that is vulnerable to solar storms. Power grids can be damaged beyond repair, GPS navigation can fail, and communication satellites can be disabled for days, weeks, or even longer. This means that airports, emergency services, banks, and even food supply chains could be disrupted, plunging billions into chaos. What if the internet went down worldwide? What if airplanes lost navigation mid-flight? These questions have become a central focus of NASA's urgent research and preparation efforts. The agency's space weather scientists are working hard to develop better prediction tools, using satellites like the Solar Dynamics Observatory and the Parker Solar Probe, which fly closer to the sun than any other spacecraft, sending back detailed data about solar activity and its effects. But even with these advanced instruments, predicting exactly when and how the next great solar storm will hit remains a challenge. The physics of the sun's magnetic fields are complex and often chaotic, and the warning time before a storm strikes Earth could be as short as a few minutes to a few hours. This limited warning leaves little time for power companies and satellite operators to protect their equipment or shut down vulnerable systems. In the meantime, governments around the world have begun to take this threat seriously. Emergency preparedness plans are being updated, and new international agreements are being discussed to share data and coordinate responses. NASA is also working with private companies that operate satellites and other space-based technologies to improve resilience and recovery plans. But beyond the technical and political challenges lies a deeper mystery. Why is the sun behaving this way? Scientists have never observed such erratic magnetic activity at this scale, raising questions about what might be causing it. Some researchers speculate that changes in the sun's internal dynamics are to blame. while others consider external cosmic influences, such as passing interstellar clouds or gravitational effects from other stars. There are even theories suggesting that the Sun could be entering a rare and dangerous phase of its life cycle, one that might lead to increased solar activity for decades or centuries. These possibilities, while still under study, add a sense of urgency and fear to the situation. The Sun, after all, is the source of all life on Earth. Its energy powers plants, controls climate, and fuels the water cycle. But that same energy, if released violently in the form of a solar catastrophe, could turn from a life giver to a force of destruction. In the face of this looming threat, humanity's vulnerability has never been clearer. While our ancestors faced storms of wind and rain, earthquakes, and volcanic eruptions, today we face a cosmic storm from the star that sustains us. And yet, unlike those natural disasters, a solar superstorm could strike without warning and affect every corner of the globe simultaneously. This raises questions not just about technology, but about human preparedness, resilience, and cooperation. Could we survive a prolonged blackout?